The first two questions on page 3 right here are very different. One's absolute value function, which produces a V-like graph, and the other one's a parabola, which is a U-shaped curve. So let's all look at number 24, and let's identify, first of all, the most important point, the coordinate HK. So what's the coordinate HK? -2, -1, okay? You always have to think opposite on H and take K for what it is, okay? So you think opposite on H, so if you see a +2, that's really gonna be a -2. Take K for what it is. A -1 is gonna be a -1. Okay, so that's the most important point. Let's graph that most important point, -2, -1, which is right here. Just put a dot right there. Now, you could draw an axis of symmetry if you want to, like the way we always do on parabolas, but you don't really have to. What we have to remember right here is from this most important point, we know that it's going to open up or down. Down because the a value is negative, and we need to remember that we treat this like if it were a slope, okay? Because this is an absolute value function, you treat the a value like if it were a slope. So just to remind you guys, this is the form that we want, that we need to have memorized, that we need to understand. The a value is kind of like our slope. That's why I drew it in blue. I always do my slope in blue. The h, you always think opposite, and the k value, you take it for what it is. So there's our hk value, -2, -1. The a value is -3. So I know that from this point, I'm going to go down 3 over 1 and put a dot right there. So it's going to be a very narrow V-like graph. And if you map it over to the other side, it'll be right here. It's a very narrow V-like graph. So let's actually draw our graph here. And that's about it. Besides that, let's state the domain and the range. And we should know that the domain are your x values. And this V-like graph that goes, that's pretty narrow, that's going down, it does go to the left forever. It's just going to be way down there. It does go to the right forever. It's just going to be way down there off this. So the domain is really x equals all real numbers. Time for the range. The range are your y values. The y-axis is up and down. Obviously, positives are up here, negatives are down here. So where's this graph? Where is the graph at? It's at the y value of -1 or below. It's at the y value of -1 or below. So how do we say that? As an inequality, y is less than or equal to -1. And that's about it. Any questions on that? All right, let's move on. Number 25. This is a parabola. Is the a value 1? No, the a value is 1/2. So we need to remember this, guys, that the a value of 1 gives us a nice, beautiful pattern, 1, 1, 2, 4, 3, 9, right? The a value of 1 will give us that nice, beautiful pattern, 1, 1, 2, 4, 3, 9. Where do we get this pattern from? From the parent graph, actual XY table, the coordinates. But this is a pattern because whenever the a value is 1 or -1, it's going to be exactly the same width as the parent graph parabola, so we use 1, 1, 2, 4, 3, 9. But right here, the a value is not 1, it's actually 1/2. So what we need to do is modify our outputs. These are our outputs. Modify them by that a value of 1/2. That means multiply 1 times 1/2 and you'll get 1/2. That means multiply 4 times 2, not times 2, times 1/2, sorry, and you will get 2. Multiply 9 times 1/2 and you will get 4.5. So your new pattern that we will use once we start graphing, we're not going to use it yet, but once we start graphing, the new pattern will be 1, 1/2, 2, 2, 3, 4.5. That's going to be the new pattern that we're using from the vertex. So the very first thing that we should do, even before talking about this pattern, should be to state the vertex. The most important point, the hk value. So what's the hk value? -1, 1. Bless you. Let's all go to -1, 1. -1 on the x, 1 on the y. It's right here. And on parabolas, we definitely want to state the axis of symmetry, that vertical line going right through that vertex. And the axis of symmetry equation is going to be x equals the x value of your vertex, always. So they might ask you that on the midterm. X equals -1. What else? So from this vertex, we know that the parabola is opening up because the a value is positive. So we're going to go 1 over and 1/2 up, because from the vertex you go 1 over, 1/2 up. So 1 over and then halfway up. So put a dot right there. Then go back to the vertex and go 2 over, 2 up. So back to the vertex, 2 over, 1, 2 up, put a dot right there. Then go back to the vertex and go 3 over, 4.5 up. So 3 over, 1, 2, 3, 1, 2, 3, 4. 0.5 is just halfway off the graph. I'm going to put my dot right there halfway off the graph. Okay, well, it's probably a little bit higher. There you go. Anyway, map them over to the other side. So we have 1 right here at this halfway point, 1 right here, and 1 up here right off the graph. Draw your parabola, and you're done. This is definitely wider than your regular parent graph parabola. Let's state the domain and range. The domain is going to be what? X equals all real numbers. The range, y is greater than or equal to +1. And that's it. So the next type of questions that we need to practice with are piecewise functions. There's 2 of them. I'm just going to do 1 of them. You guys could do that first one. I'm going to do the second one because it's a little bit easier. You guys could deal with the tougher one. Anyway, the key to writing a nice piecewise function is to start stating your lines, or the pieces of your lines, from left to right. So let's deal with this one first. And I would label this whatever type of function you want. I want to say f of x equals, and I want to put these ginormous brackets because I want to write 1, 2, 3 equations. Now, if you have different colored pens, you might want to do this. I am going to do this first line right here. I'm going to highlight it in red, and I'm going to actually write it in red. What is that equation, ladies and gentlemen? Well, think about y equals mx plus b. What's the m? How much do you rise? How much do you run? You rise 1, run 1. So the m is 1. So what's the b value? 1. So if you were to actually write that equation, you could actually draw yourself or write yourself some notes right here. It'd be y equals 1x plus 1. And you don't even need the 1 in front of the x. You could just say y equals x plus 1. Now remember, this says y equals, now you want to state the rest. Y equals 1x plus 1. Or you could just write x plus 1. Okay, that's the first piece. Now, we actually need to state what part of this entire line are we looking at. We're looking at from here to the left. In terms of x, from here, what's that x value right there? 1. And what's to the left? Less than, right? To the right is greater than. So from here to the left, we're going to say less than or equal to 1. Why or equal to? Because it's a solid dot. So we're going to write if x is less than or equal to 1. And that's barely our first line. Let's look at our second line. The second line I'm going to do in, I'm going to highlight in blue. This piece right here, highlight in blue. That means I'm going to write my equation, my second piece, my equation in blue. Now, what line would this be? Totally flat line, has no slope, crosses the y-axis at 1. What would that equation be? Y equals 1, right? Okay, so if you want, you could jot that down right there, y equals 1. Now, we know that this says y equals, and right here is where you're going to put your 1. Y equals 1, right there. Now, we need a condition. Now, this condition is a little bit more interesting because it doesn't start here. It doesn't start at 1 and go that way forever. It doesn't start at 2 and go this way forever. It's only between the x value of 1 and the x value of 2. So that's not that difficult to do. All you got to do is recognize between 1 and 2. So what's between 1 and 2? Your x's. So we're going to put x right in between the 1 and the 2. Smaller number on the left, bigger number on the right. And of course, it's going to have these inequality symbols. And of course, you need the word if right before it. So 1 if your x's are between 1 and 2. Now, the thing is this. Which one has an open dot? Which one has a closed dot? The 1 has what? Open. So that means that that's good. The solid dot implies what? there's a solid line underneath the inequality. So we're going to put that solid line underneath the inequality right there between x and 2. So that's how we do the second piece. Let's go for the third piece. If you have different colored pens, I want to go for the third piece in green. Check it out. This piece right here in green. Now, in order for me to really understand the b value, I'm going to look at the slope, which is down 1 over 2, and I'm going to extend it that way, which means it would cross right there at 1. And you know, since you could write on your paper, you could extend it. Well, let me do it with the highlighter instead so I don't actually write on it. You could extend it this way so you could see that it would cross the b value at 1. So what would that green line actually be? Y equals what? Y equals negative, what's the slope? 1/2, right? Because you actually go down 1 over 2, x, and then plus 1 is your b value. So again, you went down 1 over 2 backwards, it would get you to the 1. So it's down 1 over 2. So let's write our equation y equals negative 1/2 x plus 1 right here. Y equals negative 1/2 x plus 1. So let's write that down, ladies and gentlemen. Negative 1/2 x plus 1. Now we need the if part. If what? Now what piece are we looking at? We're looking at from this x value to the right. So what do we say? From this x value of what to the right. So what kind of inequality am I going to write right here? X is greater than 2. If x is greater than 2. Notice it's not a greater than or equal to. It's just x is greater than 2. Because that's an open dot right there. And that's as hard as it gets with piecewise functions, right? Hopefully we understand that. Let's look at number 29. It does say, state the domain and range of the above piecewise function. So, do any of these pieces go to the left forever? Yes, the red one. Any of these pieces go to the right forever? Yes, the green one. So what do we say about the domain? That's right. The domain is x equals all real numbers. How about the y's? Do any of these pieces go up forever?
No.
No. So it stops right here, right? In other words, you could think of this is your maximum point, and the rest of this is all below that maximum point. Okay? So how could we say that this piecewise function has a maximum point at 2 and everything else is below 2? So it's at or below 2. So how do we say that? Y is less than or equal to 2. That's right. So for my range, we're going to have y is less than or equal to 2. Okay, so you understand that one. Hopefully you'll be able to do this guy right here on your own. Let's go to this next portion. I'm only going to do one of them. And let's all do this. Let's all underline the word translation. That's a vocab word that we rarely use. Most of the time I say the word shift, right? So everybody write down right on top of it, shift. But we need to know this, that the word translation means shift, all right? So let's go through each one of these, or actually I'm just going to go through one of them. You guys are going to go through the rest. But what would the shift be of this V-like graph if you think about the parent graph compared to this new graph? What would the shift be? What would you say? 2 to the right. Ta-da, piece of cake. And you guys should be able to look at this one and say, oh, well, this one was my H. That's why I said I thought opposite. That would mean 2 to the right in the positive direction. Do I have an H here or do I have a K here? K. So what's my shift on this one? I might as well do it. What's my shift on this guy? 5 up. That's right. So 5 units. I didn't use units on the first one. I probably should have. 5 units up because the K value is 5. Over here, the H value was 2. So that's why it's 2 to the right. The K value is 5. That's why it's 5 up. And that's about it. You guys could do the rest. Let's jump to 34 through 36. This is a final piece on this page 3, the front side. 34. What would be the first transformation? Now check this out. From the parent graph, always go through this process. If your A value is negative, that's a reflection over the x-axis. If your A value is a number greater than 1, that's further away from 0, then that's a vertical stretch. If it's a value that's closer to 0, then it becomes a compression. A vertical stretch means it gets narrower. A vertical compression means it gets wider. And then, of course, your h and your k, that's your final transformation, which is a shift left or right and up or down depending on h and k. So what would we say is the first transformation that we describe right here? Reflection, where? Over the x-axis. So everybody please write down on number 4, write down reflect over the x-axis. And it is reflecting because the a value is negative. On number 35, you're not going to say that the first thing is reflected over the x-axis because it didn't. There is no negative in front of the a. So the only time you say reflected over the x-axis is if it's a negative. Now, after you say if there's a reflection or not, you got to look at this value. Is this value closer to 0 or is it further away from 0 than 1? It's closer to 0, which means that it's going to get smashed. It's going to get compressed. It's going to get wider, right? So our second description of the transformation would be it gets vertically compressed by 1/3. It gets wider, okay? Now they're not going to write the word wider on the midterm, but it is vertically compressed by 1/3. I'm just letting you know that vertically compressed means that it gets wider. And my final transformation is according to the h and k, and that's what we call our shifts, or you could say translations as well. You could say translations as well. So I want to go with the word shifts. So the third thing is that it gets shifted 2 units to the left and 4 units down. Again, you think opposite, so that's really thinking -2. So you're going to be going 2 to the left and 4 units down. So you guys could do the same for 35 and 36. It doesn't matter if you're dealing with an absolute value function which produces a v, or a parabola, a quadratic function that produces a u-shaped curve. It's all the same, right? Does it get reflected? Is it a vertical stretch or compression? What kind of shifts do you have? And that's about it for this front side. Let's work on the rest for a moment.